Welcome to my YouTube channel on testing your knowledge on math, bio, chemistry, and physics, where we go through GCSE questions on these topics. So I want you to do this question for me, okay? So I want you to pause this video, take your time, do the question, and then type your answer in the comment box. And if possible, like this video and subscribe, because I'm going to be doing lots of these videos each day. What is a supernova? Now, a supernova is when a giant star explodes. So this, when I mean a giant star, I mean a high mass star. A mass round about more than our sun, maybe 2 or 3 times more than our sun, and it explodes. Now, when it explodes, it creates a supernova, so it contracts. There's no more fusion going on. So when there's no more fusion going on, there's no more outward forces pushing the star outwards, okay? So when the star is in its normal phase, it's got a balance of the outward forces pushing it outwards and gravity trying to pull it inwards. When you lose that fusion process, gravity happens very quickly and a giant supernova happens. Now, what is the longest wavelength? So the longest wavelength would be infrared. So that is more to do with the heat. So infrared would have went from here. The shortest wavelength, okay, then it goes to visible light. So visible light is the one we can see. Now, the interesting thing about infrared was it was discovered by a thermometer. So a person split up light by putting it into a prism. The colors all split up into different colors. He put the thermometer past the red spectrum. So you could see the red. He put the thermometer past the red spectrum and he saw the thermometer's temperature went higher than it did with red. And then that was where infrared came out, because it's something we couldn't see, but we knew it existed because it made the temperature of the thermometer go sky high. Now, which one has the shortest wavelength? So the shortest wavelength is X-rays. That is why you want to limit the amount of X-rays you get per year, because they can cause mutations in the cells, and that is not great because it could increase the risk of cancer. But sometimes X-rays are beneficial. So your doctor will make that decision whether it is worth getting an X-ray or is not worth getting an X-ray. Because if you don't get the X-ray, you could end up with a serious problem that can lead to death. Let's just put it like that. Okay, so explain how using different telescopes can give us a better understanding of the universe. Now, different telescopes tell us different information. So some telescopes detect infrared radiation, which will tell us some information. Gamma ray radiation. Gamma radiation is really given off when neutron stars are, for example, colliding, or very high impact, high amount of energy being released. So you will see gamma rays, but different telescopes will tell us different information. Also, so we'll collect different electromagnetic waves, so as in gamma rays, infrared, and so forth. And more magnified images. Now, space telescopes are the one. So space telescopes are above the Earth's atmosphere. So the Earth's atmosphere will filter out, will absorb a lot of the gamma radiation, X-ray radiation, and so forth. So that doesn't give us so much clear images. This is why we try and put some telescopes near on mountains or even on aircrafts to try and get a better image, but you can't get anything better than going into space. So the space telescopes are the ones. And the Hubble telescope, I think the recent one, went for $1.5 billion or something like that they spent on it. Now, most telescopes orbit the Earth, but the Spitzer telescope, which is the one that looks at infrared radiation, stays behind the Earth to hide from the sun. Why is that? Because the sun gives us a lot of infrared radiation. So you want the Spitzer telescope just behind the Earth. So as the Earth is rotating around the sun, you want the Spitzer telescope just behind the Earth, okay? Because the sun is releasing an immense amount of infrared radiation, and you won't be able to detect other different infrared radiation, maybe infrared radiation given off by a certain black hole, or maybe given off by, for example, a supernova explosion or a neutron star or so forth. You will be missing this type of information because you'll be oversaturated with the infrared radiation given off by the sun. So if you enjoyed this video, please subscribe. I'm going to be hosting biology, chemistry, math, and a lot more videos. Take care, have a nice day, and bye-bye.